Hi guys, and welcome back to the last video of Physical Science Year 10, where we're looking at electrical and sound energy. So this is the last video that we're going to look at the specific types of energies. So we're going to be looking at, as I say, electrical and sound energy here. Now electrical energy basically is the energy which is possessed by electrons. Now electrons are tiny negative particles which exist surrounding the atoms. Now we studied this in chemistry, but those electrons can be tightly bound or they can be quite free. If they're free, then they have the ability to move from one atom to the next, so we get a flow of electrons. Sometimes we can get large amounts of electrons packed at one end of a circuit. Now in a battery we do this all the time. We have a positive and a negative terminal. Now electrons basically are negatively charged. Now we know that like charges repel each other. So if we pack lots of particles together which have like charges, the result is they are going to push back. Now that pushing back actually generates energy. So when you've got the negative end of a battery, that's the one which doesn't have the metal bits sticking out. When you've got that flat end, what you've got is lots and lots of electrons packed at that end. And what they want to do, they're all tightly packed and they want to get out. So that wanting to get out is the energy which is generated. Now what we then do is that we allow them to flow through conductors. Now the main conductors, we've got electrical wires. So what we do is we make up a circuit similar to the one that we've got in the picture there. Now what will happen is the electrons are already present in the wires. So as soon as we turn the switch on, what happens is we allow those electrons to move from an area where they're tightly packed, the negative terminal, to an area where there's plenty of space, the positive terminal. So what they do is then they move or are pushed through the wire as quickly as possible to the positive terminal. Okay, now what then happens is we've got different amounts of push depending on the repulsion. So if you've got a big battery, you've got a huge amounts of repulsion, which means they'll flow quickly. We can also slow the flow by putting resistors in there. Now we study all that obviously in electrical, when we do our electrical energy units. We studied this in year 9, and you'll also study it, as I say, in senior physics. But what I want you to understand is that the electrical energy which we get coming out of the plug socket is due to a repulsion of electrons because they are like charges. Now if you look at the diagram below, you can see you've got your two like charges there. The red line basically shows that they're both negatively charged and they are pushing away from each other. You pack them together at the end of a terminal, then as soon as you release it, bang, off they go, and there's a huge amount of energy which will flow through from an area where they're all tightly packed to an area where there's plenty of space. Okay, so that's how the basic principle behind how an electrical circuit works. Now, as those electrons move through the wire will give up a wee bit of resistance. That resistance will generate heat, and sometimes it will generate light. So obviously when you see a wire glow, for example in a heater or in a hairdryer, you look at the back of a hairdryer or at a light bulb, you'll see it glow. As it's glowing, there's a huge amount of energy being released because it's trying to push its way through the wire. We're giving out light and heat energy, which we talked about earlier in the last video. So that electrical energy can be converted. Now that's great if you're in a heater or a hairdryer. It's great if you're in a light bulb and you want to generate light. But ever picked up your phone or your iPod or your computer and touched the back of it? It's warm. That's because that electrical energy is flowing through, but some of that energy is coming out. So we've got electrical energy flowing through, which allows us to give us our light. In the case of the screen here, that's really, really good, so I can see what's going on. But I'm also getting heat on my computer here because there's resistance within the wires. So what I'm trying to get over is that electrical energy is due to that repulsion, and then that energy can be converted into other forms of energy. Some of it's useful, some of it's not useful. Now the last energy we're going to be looking at is sound energy. Now There's not a lot to say about sound energy, bar the fact that it's the energy possessed when you vibrate air particles. Now, the top diagram here shows a speaker with an ear, and what you can see is that as the speaker moves, it's an electromagnet, but as it moves, it pushes the air. Now, the degree with which it pushes links with our ear, and due to pressures and the fluctuations of the eardrum, that can be converted into an electrical signal, and as a result we interpret that as sound. So sound basically is vibrations of air particles. As we say, the louder the sound is, we can either say the louder the sound is, or the higher the pitch of the sound, the more sound energy. Obviously, the higher the sound, the more sound energy than a lower sound. So you get the rough idea. So an opera singer breaking a glass basically is down to a concept of high pitch causing the glass to vibrate. It vibrates because the air particles are hitting the glass. Take a finger, wet it, and run it over the top of a wine glass, and you'll hear it vibrating. It's not really the glass. Well, the glass is vibrating, and what it's then doing is vibrating the air inside the glass, and that sound is then picked up by your ears, and we hear it as a hum. A guitar works in exactly the same way. You strum a guitar, it vibrates. It vibrates the air, which is then picked up by electrical pickups, and the result is it comes out as sound, which is pushing the air from an amplifier. If you look at the bottom diagram, this is showing a string which is vibrating as, obviously it's speeded up, but as it's plucked. Now work has to be done in order to push the air particles from one place to the next. So again, you get this idea of this transference of energy from one type into another. All the time, work has to be done in order to cause that energy transfer. So again, sound can be a really useful thing, especially in things like an iPod, stereo, etc. Can be something that we need, which is wasteful in things like car engine. If you can decrease the sound in the car engine, then it's so much the better. And the sound is generated more often by the particles or the parts of the engine rubbing over. We try and get over that by oiling them up and lubricating them to remove that sound energy, so there's not so much wastage of energy. Well, that sort of finishes all the work that we've done on the different types of energy. Hope you found it useful. Hope it's given you a better insight into what the types of energy are. Obviously with the kinetic and gravitational potential energy, I hope you've learned how to do the calculations. So join me again and we'll start looking at further aspects of our alternative energy unit. Thanks for watching.